Good day, students and viewers. You are welcome to the studios of Maths X. We are still on fractions, decimals, and percentages. In our last video, we started with the fractional part of this particular course, and we did justice to the definitions of fractions and what a fraction looks like in terms of appearance. We also discussed the 7 types of fractions in mathematics. And then we showed you how to convert from improper fractions to mixed fractions and vice versa. In today's video, we are going to consolidate on what we have done. We're going to start with the first operations, the first fractional operations being the addition and subtraction. Happy viewing. So for our next subunit, we're going to look at basic operations with uh, fractions. Basic operations with fractions. And the first operation I wanted us to do with fractions is addition and subtraction with fractions. So how do you add and subtract with fractions? Here are a couple of examples that I wanted us to do. As much as we can, we're going to be looking at addition and subtraction of proper fractions, addition and subtraction of proper and improper fractions, addition and subtraction of uh, uh, proper and mixed fractions, and of course, addition and subtraction of mixed fractions. So that's what we are going to do, because like I told you earlier, the first 3 types of fractions I gave you are the mainstay. There are most people that will tell you that they know about only 3 kinds of fractions, and every other kind of fraction is gotten from the main 3, which is the proper, improper, and the mixed fractions. Okay, so these are some examples, simple examples that we just want to go through before we go to the next operation. Let's try our first example, the A part. We have that A, we have 2 over 9 plus 4 over 9. This is the addition of like fractions. And like I told you, it's very easy. All you need to do is just retain the LCM since it's common to 2 of them, and then just add the numerators, or maybe even subtract as the case may be. So all I need to do is just 2 plus 4, and we end up having a 6 over 9, which we reduce to our lowest term, because you must reduce to lowest term. And 3 into 6 is 2, 3 into 9 is 3 itself. So that's our final answer. It's as simple as that. So to solve fractions when you are working with like fractions is the easiest thing to do, because all you need to do is just add the numerators, retain whatever you have as the denominator, which is its common LCM. All right, now let's look at the B part of this. This one is a bit divergent. These are addition and maybe even subtraction. These are addition of unit fractions. So because there's a 1 on top, and we said the 1 should be positive. So we have 1 over 2 plus 1 over 3. For this particular one, since they are unlike fractions, yes, they are unit fractions, but they are unlike fractions. The denominators are different. We will have to use our LCM, and here our LCM is 6. So you will say 2 goes into 6 times 1. We still have 3. 2 goes into 6 times 1, and we have a plus 2. So our final answer is 5 over 6. This is reduced to lowest term. There isn't more we can do on that. Let's look at the C part of our exercise. So we have 4 over 5 minus 1 over 3. Okay, our LCM is 15. So 3 into 15 is 5 times a minus 1, because that's what we have here, and that's a minus 5. 5 rather into 15 is 3 times 4. And we have what? A 12. So 12 minus 5, what we have there is 7 over 15. Let's look at the D part of our example. We have a mixed fraction, and we are subtracting a mixed fraction and a proper fraction. So we have two whole number, 1 over 2 minus 4 over 5. First of all, there's nothing here, so there's a 2 here. Our LCM here is 10. I trust we are together. So 5 rather into 10 is 2 times minus 4, because that's what we have here. This is a minus 8. 2 into 5, 2 into 10 rather, is 5 times 1, and that is 5. Now, from here, 5 minus 8, most students will say cannot. It's okay, but this is what you do. You will borrow 1 from the 2 here, so that what you end up having is 1 is here now. And whatever you are, the one you are borrowing here is what is the LCM. And the LCM here is 10. So you would add 10 plus 5, 15. 15 minus 8. So what we end up having here is one whole number, because 1 is now here. We borrowed 1 from here, from the 2. So we have 1 left. So, and that 1 we borrowed amounts to whatever the LCM here is, and we have a 10 here. So 10 plus 5 is 15. 15 minus 8. 15 minus 8 is a 7. So we have 7 whole number 1 over 10. This particular type of subtraction or even addition, I've had cases where my students will want to turn everything to improper fraction. That still works anyway, but you can subtract conveniently with your mixed fraction. All you need to do is that whatever the LCM is, when you are borrowing a particular, when you are borrowing to subtract, like in this kind of case where they will tell you, it cannot, whatever you are borrowing is the LCM. I can still do this maths again, but this time around, working the maths as improper fractions. It will still work out. For this same example, D, let me still work it again using the improper fraction method of it. I see most students do it. So what we have here is 2.5. This is 2 times 2, 4, plus 1, 5. So I have still D, which is 2 whole number, 1 over 2 minus 4 over 5, rewritten as 5 over 2 minus 4 over 5. Doing this, my LCM is 10, right? 5 into 10, 2 times minus 2 into 10, I mean to say, 5 times 5 is a 25. So 25 minus 8, 25 minus 8, that will be 17 over 10. 17 over 10 is one whole number, 7 over 10, which is still what we had here. So I've seen my students choose to convert this particular mixed number into an improper fraction to be able to solve. But what I'm saying here is that you don't need to do that. You can still go ahead and solve without converting to improper fractions. You can solve it as, you can do the subtraction as a mixed number. It doesn't change anything. So that's why I'm doing this class online, so that many of my students, and maybe the ones watching from across the world, can see that this can be done. Let's look at our E example. I might be forced to clean at some point, so do bear with me. So for the E part, I have 5 whole number 2 over 3 minus 2 whole number 5 over 8. In solution, First of all, 5 minus 2 is 3. Then we have our LCM. The LCM of 3 and 8 is 24. 8 into 24 is 3 times minus 5 is minus 15. 3 into 24 is 8 times 2 is 16. So we have 3 whole number 1 over 24 as our final answer. Let's try, of course, the last but not the least. This is also addition of a mixed fraction. This was the subtraction of a mixed fraction. So for our last operation on the addition and subtraction side, first of all, we add 1 plus 3 is 4. Our common LCM, 7 and 4 is 28. All right. So 4 into 28 is 7 times 3 is 21. There's a plus sign here. 7 into 28 is 4 times. 4 times 4 is 16. So what we end up having here is 4 whole number. 6 plus 1 is 7. 1 plus 2 is 3 over 28. Still moving on, 28 into 37 is 1 time, remainder 9. So, and that one that we just got, we're going to add that one to 4 here. I'll take it again. 28 into 27, as in 20, using 28 to divide 37, I mean to say. 28 divides 37. It can do that 1 time. And we have a remainder of what? 9. That one we had will be added to our 4 here. So we have 5 whole number, 9 over 28 as our final answer. The next operation I want us to go into will be multiplication. Multiplication of fractions, and we'll do it much the same way we did the addition. We're going to talk about multiplication involving proper fractions, multiplication involving proper and improper fractions, multiplication involving mixed fractions and proper fractions, as well as the improper ones also. So we're going to just try to see how we can mix up each of the fractions in our multiplication operation. So, my dear students and viewers, for our second mathematical operation involving fractions, we will be multiplying fractions. We have 4 exercises to help foster our understanding. Before we start, it is good I tell you, my dear students and viewers, that fractions tend to multiply diagonally in sort of an X way. So from the top to the bottom, as in from the numerator of the fraction of this on this side to the denominator of the fraction on the other side. The same thing goes from the numerator of the fraction of on the left hand side to the denominator of the fraction on the right hand side. So fractions multiply diagonally, and also they can also do so as a multiply or up and down. That is, the numerator cancels the denominator, or maybe the denominator also does the same to the numerator. So you can go up and down or diagonally in an X pattern. So let us try the first example here. For the A part, we have two proper fractions. So we have 2 over 5 times 2 over 3. The first thing we look for are factors. Can anything cancel itself diagonally? 2 can't go into 3, of course, without a remainder. 2 can't go into 5, of course, without a remainder. So nothing works, nothing cancels diagonally. Then, of course, you check it up and down too. 2 can't go into 5 without a remainder. Same thing also, 2 can't go into 3 without a remainder. Now, when this happens, my dear students and viewers, what you do is you multiply the two numerators, multiply themselves, and also the two denominators do the same. So what we end up having here for the multiplication of these two proper fractions will be 2 times 2, which is 4, over 5 times 3, which is what? 15. And our answer is another proper fraction, and that is where it ends. Let's look at the second example. This is the multiplication of 3 whole number 1 over 2 times 4 whole number 4 over 7. This is the multiplication of two mixed fractions. For this multiplication to take place, the first thing we need to do, my dear students and viewers, is to convert these mixed fractions to what? Improper fractions, for us to be able to multiply with them. So for this conversion, I showed you this in our previous video. This will be 2 times 3, 6, plus 1, 7, which is 7 over 2 times 7 times 4, 28, plus 4, 32. So that will be 32 over 7. Without wasting time, we check 7 here, 1. 7 cancels 7, as in 7 cancels itself one time. 2 into 2, 1, and into 32, 16. So our answer here is 16. Let's take some space on this other side to accommodate some more examples, my dear students and viewers. Let's look at the C part of these exercises. For the C part, we are multiplying a mixed fraction and a proper fraction. So for the C part of our exercise, we have 3 whole number 1 over 2 times 4 over 7. Like I told you, the first thing we do is to convert the mixed fraction to an improper fraction. So 2 times 3 is 6, plus 1 is 7. So we have 7 over 2 times 4 over 7. Like I told you, the multiplications are done diagonally. You first of all go this way, 7 into 7, that's one time. That's one time, and of course, 2 here, 1, 2 here, 2. So our solution to this particular exercise is 2. Let us go for the third part. For the third part, I see two improper fractions multiplying. Well, so for the third part, that's D, we have 7 over 2 times 16 over 7. There's plenty of 7 in our exercise or our exercises. 7 here, 1, 7 here, 1, 2 here, 1, 2 here, what? 8. So that is your final solution for this particular example. So I hope, my dear students and viewers, you have seen how to multiply fractions, whether as mixed fractions or proper fractions and improper fractions. So, my dear students and viewers, this is the much we can take in today's class. We trust you have learned how to add and subtract different types of fractions, and also how to multiply different kinds of fractions. We trust you've been thoroughly enlightened. In our next class, we will learn how to divide using different kinds of fractions. And of course, we will get into a little bit of decimals. Till then, keep on watching the videos of Maths X. Like, share, and subscribe. As you do so, God bless you real good. Thank you.